Hi, I'm Colin Roache. I work on Adobe Design Lab, which is an incubation lab within Adobe Design, which is an organization within Adobe that's responsible for overseeing the overall arc of the brand and the company and design within the company. Within that group, within the design lab, I'm a senior developer and I do prototyping-based iteration where we test ideas, prove them, and then sell them around the company to make change, often by promoting our own ideas, but also combining research. So I've been in this field for a while, and it's a little bit hard to define. But it's essentially futurism prototyping, where we look forward and we think about what sort of technologies we would like to see in the future, and then we test them out, and we try to figure out a path to evaluate that idea, and then to arc technology towards that goal. There's a lot of detail and theory around this, but one of my most salient mental models that I use is what I call the futures past, and this is being used by a lot of different futurists and mystics, and it's a pretty simple idea. It's essentially looking forward in time and then looking back. So what do I mean by that? Okay, so here we are right now, state of technology. We know apps are cool, we know web is cool, data's coming up. Okay, great, grab a tool, let's build something. Well, that kind of leaves us in the same state that we've been in, where we keep compounding on past lessons. This is a learning-based action model. Futurism is essentially the inversion of learning. Instead of basing our actions from what has happened, we look forward and say, what do we want to happen? And then from that future stance, look backwards and say, what should we change now? So for an example, if I were a year in the future, what technologies do I think would be more prevalent than they are today? Sure, databases, network exchange, but also deep integration with Internet of Things and connectivity between our devices and what's around us. Now, most people will push back and say, well, there's not the infrastructure to support that in this world, right? People don't have IoT devices that they can just connect to. We shouldn't invest in that. But that's really a learned action model. A future action model is like, we see that IoT devices are becoming prevalent, so therefore we're gonna start building technologies now that anticipate that need. Okay, so that's kind of the overall gist of futurism-based work. I apply that model to the design and implementations of my experiences, and actually my whole organization, Adobe Design, does. We take what's called an experience-driven design approach, where instead of saying, what are our inputs for our problem that we're trying to solve, we say, what are our outputs? What do we want to have happen? What's going to be the final effect on the user? How are they going to feel? How are they going to respond? What is this going to do? What do we want them to do? And then how do we shift what we do to guide them towards that? So this has very many implications across a wider range of technological and societal development paths. But it also plays a lot into how I build and think about data visualization and interactive data visualization. A lot of what I focus on and a lot of what Adobe focuses on as a whole and why I was attracted to Adobe as a company is because they focus on tooling. Not so much as specific experiences or single-use apps that come with a specific output, but really general purpose tools that don't give the user bias or do their best not to, and to really lay themselves for the user to allow them to express themselves to the fullest. And when we apply that methodology to data visualization, we can start to look at data visualization as a tool or a lens into a larger reality, right? So in our experiential reality, there's infinite metrics and values which we can record. So any data set is going to be a subset of the data which could be derived from reality. So when we're doing data visualization, we are in essence navigating users through a story of a perception of reality, right? So by building tools and focusing on tools and abstractions rather than solving individual problems, we can solve very many problems at once. So, where are we now? Where's the current state of technology? We're in, especially in regards to data visualization, we're in the state where computer graphics has built since the 70s. We have all these really advanced tools that have been driven mostly from video games to do real-time rendering. We also have an enormous academic lineage of human-computer interaction and interaction design research that thinks about how users engage with digital experiences. And then we have data science, which as a labeled field is kind of the newcomer of the bunch, but has really been around before all of them, and no one really knew what to call it. I come from computer science. When I first heard data science, I thought that was kind of silly. Now that I've been to a lot of data science conferences, I get it. There's a specific viewpoint where you're just looking at data. Not even computation, really. Like you're looking at mathematics, you're looking at data flow. And computation and computational theory is almost left as like a black box within that field. So we have a lot of wisdom from these three fields, and they come together in a trifecta within data visualization. However, since they've developed from independent states, they're now in a trichotomous state where there's overlapping lexicon with different meanings. Different fields have solved different problems in different ways, and there's not a lot of overlap. So what I apply in my work and what a lot of my colleagues apply is really a first principles approach to data visualization. What is a first principles approach? It's looking at a problem and saying, if I knew nothing, absolutely nothing, I had my reasoning and no knowledge, and I were to come up to this, what would I conclude? How would I use this? And obviously there's a lot of instances within our society where you can't just look at something and get all the context face value, but there's a lot of conscious unlearning that has to happen in order to escape from like, how do I apply an example data visualization to my data into how do I create a meaningful experience that tells a convincing story to my audience with my data? So we have a very interesting case with machine learning because how machine learning works is you define a learning network, or a learning algorithm that has some method of seeing data and then making what's called a model. Now, a model has, this is again one of these cases where there's multiple meanings. Within design and engineering, when we talk about model, we're talking about a mental model of some sort of patterns, some way that things are done. When we go into machine learning, the model is what is learned. It's the information that after the process or algorithm seeing data stores in order to make future predictions or decisions on new data. So there's a overlap there that many people should be aware of. And we have an interesting situation with data visualization and machine learning, because usually machine learning requires an enormous amount of data to really apply results. However, we can see trends in data visually with data visualization much earlier than current algorithms can see in data, right? So what we can do, or what we end up with, is a bootstrapping chicken and an egg problem where we need more data to learn from it, but then we can't make the experience to collect the data unless we have insights into that data from which to know how to navigate it. So we can use data visualization as a tool in order to navigate us through the machine learning development path, especially in cases where we don't quite have enough data to make informed decisions about what the best route of learning would be. Data visualization, hand in hand with machine learning, can allow us to see trends before a stock algorithm would. So how do we do this? We first take a look at what our data is, like how our data is coming in to us. Do we have numbers? Are they metrics? Are they time series values? Are they graph data? Are they relationship data? What are the balance with our data? Because when we talk about making decisions from data, we usually cut some of it out. We can't look at the whole picture to inform our decision. So allowing us to see the data as it comes in will let us see how the machine is interpreting the data as we go along. So one key finding from my work within my design prototyping lab has been to synchronize what happens in the visualization with what happens in the experience. So what do I mean by this? We have, when we're talking about analytics data from experiences, right? We're talking about building an application or a website that users interact with, and then we record metrics through instrumentation, right? Analytics. You say this user went to this page, this user went to this page, and we can track how they navigated. As we get that data in, when we build machine learning algorithms to make decisions from that data, it reflects to the user, right? So once we have an application which responds to machine learning, we have an opportunity to show data in the same context where decisions are being applied. So for example, if I had a page And I have to be honest and apologize. I expected to have a demo of this particular solution available, but it has been tied up in a patent submission, so I can no longer show that code. However, the basic gist is thus, is that when we have experiences that respond to user data, we have an opportunity to show the data in context of where the data comes from. So for example, we can take a heat map of mouse paths or mouse clicks or ways in which somebody interacts with an element on a screen and draw those visualizations on top of the actual experience. I went over that. So when we talk about looking at what data we want to show in the experience, what parts of the user experience data we want to navigate, we have to look at the dimensionality of the data that we have. So mouse clicks can be seen as in multiple forms, right? So if we have raw mouse data, we have maybe just a table with clicks and URL and user, but we also have a lot of other dimensionalities and forms of data that we can derive from that. So for example, we could create a graph. And when I talk about graph, I don't mean a chart, which is an actual 2 or 3D plot on screen, but a graph has in terms of a mathematical graph where you have nodes with edges connecting them. So you can look at your data, say you have mouse clicks, you can look at it as just a table with mouse clicks. You can look at it as a time series. You can look at it as a graph. And then you can also look at, and the graph would be where one click led to another click, right? And then you can also mix how these data models are used. So for example, if you had mouse click data from an experience, and a lot from many different users, and you had information about how they navigated through different screens, as you're drawing that, you can have an analyst experience, right? Where you go into your experience and look at it in context of the experience itself, but also the user data that you've recorded about that. So you can show just the mouse clicks, but you can also show frequency data. You can show different counts for different paths that have gone off to different objects. How do we think about this, right? We have a lot of data. We have information from our application irregardless of user analytics, but then we also have user analytics, which could be informing the experience itself. One of the most important things to do when building experiences which react to data is to be able to have introspectability. So you want to be able to go into your experience and say, what happened here? If I was a user, what happened, right? So what we can do is we can build a patterned model of both the user experience, which is the user's in a state, then they take an action. That action then modifies the user interface state and maybe some data store, and then it's re-rendered, and then the user again has a choice. to make an action, and then that action changes the application state. So this is the basic flow of the user. Now, when we talk about the data collected from this and analyzing and making sense of this data, we also have that same pattern, but for the analyst, right? So we have the analyst going in and looking at some data and then making a selection, maybe inspecting one element or filtering down the data or changing their query. And then they may want to see an actual user experience, like what happened here. If you're showing analytics and visualizations of what happened in your user experience, you have an opportunity to allow the analyst to dive into that specific user experience, right? So if we model our application state as just an object, and then we have user actions as modifications of those objects, where we have state continually changing as users take action, then we can also wrap that in an analyst context where the analyst is looking at the state of the data, state of the output of the application, the metrics, and then making a change to their query or to their filter, their view, what have you. There's a golden opportunity here wherein we can allow the analyst to replicate the user path, right? So we can have part of the analyst path to play back part of the user path. And this is something I found very helpful when looking at a lot of user data. Sometimes I have an outlier and I'm like, what happened here? What is this data? And without having a way to take a data point, take user metrics, and push them back through your user experience, you can actually see what happened, you start to lose the context of your data, right? Once we have user clicks, but like we have like a pixel location, but we're not really able to see that on the screen, we can start to make algorithmic decisions. We can make decisions algorithmically, but it's hard to make algorithmic decisions about which algorithm we should choose, right? So in order to develop systems like this, when I'm building my code, I think about three main aspects. The first one is introspectability. So it's really, can I find out what's happening at any given point? And this is really what building a state action interaction model allows. One of the powers of this model is that we can have a history of the interface state as an object, and then we build a time series out of state action, resulting state action, resulting state action, right? Being able to introspect that process is key in breaking down our user experience into discrete object states and actions allows us to see what happened over time, right? We can play back this series and see how the entire application changed. So then once we have a user model and user state model and an action model, we need to define interaction code that modifies the state and provides those actions, and then a graphics module that actually renders the state. So I find a really clean way to decouple interaction experiences. And then you can apply that to building both the user experience and the analyst experience. So yeah, essentially a data experience as I view it and use it is an interleaved series of actions and updates to the state. So, what is really a data visualization? Data visualization is visuals onto data. So this is a subjective term. And if you remember from math, or perhaps you don't, so we have two functions here, x and y. And the values shown in x represent inputs to a function, and the values in y represent outputs to the function. Onto means that for any given input, there is one and only one output. Okay? That last part is crucial. One and only one output. So, when we look at, when I look at a lot of interactive visualizations online, well, let me rephrase that. When I look at a lot of data experiences online, I don't always see visualization because they'll enter into this finicky state where if I move it, if I play with it, it renders differently. And it gives me this sense of like, I'm not sure if I got it all. I don't know if I saw all the data. And to me, the way I see it is a visualization is really a function which takes data and represents it visually. So then what is this other thing? What is it when you have something that's responding to data? Maybe the colors are changing, there's an animation and the wind goes faster when the weather gets cold, or there's a wide variety of data-backed experiences. And I call these reactive graphics. It's graphics reacting to some data-based state, but it's not necessarily onto the data. Now, here's the interesting thing. Interactive visualization is inherently not onto the data. However, as I see it, interactive visualization is two parts. It's the interaction, which is like setting the viewpoint of the data, right? It's selecting what we view in the visualization. And then that selected data subset goes to the visualization and is onto. And this is a really key determining factor because it requires, in order to have a full data visualization, that the reactive graphics part of the interaction exposes the limits of the data, right? So even if we're not showing all the data, we want to show context and we want to show where the user is and where they can go, ideally where they've gone before, but we don't want to leave the user with a sense of exploration, of unsolved or unresolved exploration. There's a tremendous amount of opportunity in this space, but I personally don't consider that visualization as in a tool for data insight. So interaction can be reactive in order to deepen the visualization model. So this is essentially what I just said. And the interaction model may or may not be injective one-to-one. So one-to-one is similar to onto, but instead of 3 and 4 going to C, 4 would go to D. It means that every input has a unique output. And that may or may not be true with the interaction model, but as long as the interaction model allows the visualization to wholly render the data in a reproducible manner, then the interaction can allow the user to explore a larger subset of data. So again, this is what I just summarized. When designing interaction, any interaction which reduces the view or dimensionality of the data should convey data context, navigation, and coverage, show how much of the data is exposed to the user and how much is left. So in order to build these, it's all about bootstrapping from instrumentation. So you build an initial prototype, you get your metrics, you start building visualizations on top of the experiences that you've already built so that you can start to see the trends in your data. As the data starts to come in, you can start evaluating and visualizing different learning models on learning methods on the data. And can further hone in on your user experience. And that's mine.